Good day. For this lecture video, I'll be talking about constant pressure and constant volume calorimetry. The following are the lesson objectives. Number one is to differentiate bomb calorimeter and coffee cup calorimeter. The second is to simply show calculation on heat changes using constant volume and constant pressure calorimetry. We start by defining what calorimetry is. Calorimetry is simply defined as the measurement of heat changes within a chemical reaction or other physical processes. Okay, so take note of the keywords. Calorimetry is simply the measurement of heat changes within chemical reactions. Calorimetry is also associated with determining the changes in energy of a system by measuring the heat exchange with the surroundings. Okay, so again, calorimetry is also associated with determining, calculating the energy changes of a system while we measure the heat exchange with the surrounding. So again, let me repeat. Calorimetry is defined as the measurement of heat changes within a chemical reaction, and calorimetry is associated on determining or calculating the energy changes of a system through measuring the heat exchange with the surrounding. Okay, so the heat exchange between the system and the surrounding. So that's calorimetry in a nutshell in terms of technical definition. Now, there are two types of calorimeter that we need to discuss in this lecture video. So number one would be constant volume calorimetry. Now, what about this one? Heat of combustion. Okay, so that means combustion is usually measured by placing a known mass of a compound in a steel container called a constant volume bomb calorimeter. So that means, should we want to measure the heat of combustion, gusto po natin alamin ang heat of combustion, atin pong nasusukat sa pamamagitan ng paglalagay ng isang compound na mayroong known mass sa isang container. Ang tawag po sa container na yon ay constant volume bomb calorimeter. Ulitin ko po, heat of combustion. Okay, combustion can be measured by simply placing a known mass of compound in a container, and that container is called constant volume bomb calorimeter. In other words, for us to measure combustion, okay, we use a known mass of a compound inside a constant volume bomb calorimeter. So that's the purpose of a constant volume calorimeter. Okay, this particular calorimeter, constant volume, measures combustion. Okay, so should we measure combustion, or the problem would like you to solve for the heat of combustion of a certain compound? The type of calorimeter or the type of computation or calculation is anchored on constant volume bomb calorimeter. Okay. Now visually, this is how a typical bomb calorimeter or a constant volume calorimeter looks like. So you have here, this is the container, the steel container, and then within the container you have here the place where the system where we put the particular substance. Okay, so the substance here is allowed to combust. Okay, and then the power is electrical source, and then you have here a thermometer measuring water inside. So let us look at how the process is being done, the simple process in a nutshell. The sample is ignited electrically. So this is a sample, and for the sample to start to combust or to start to be ignited, we use electricity, electrical energy, or electrical source. And the heat produced by the combustion reaction can be calculated accurately by the rise in temperature of water. So the moment that the sample combusts or does combustion, the heat produced by the combustion, okay, look at the arrow represented the heat being transferred. The heat coming from the combustion, okay, will be measured through water. So remember, yung heat po ay matatransfer dito sa water. And then yung water po, kapag yan po ay umiinit, ma-record po natin ang temperatura sa pamamagitan ng thermometer na to. So we can measure the heat of combustion or accurately record the rise in temperature through water. So from combustion, the heat being released by the combustion will be transferred to water, and then water's rising temperature shall be measured by means of the thermometer. Okay? The heat given off by the sample is absorbed by the water and the calorimeter itself. Okay, so water. Okay, so this one, the blue shade, that is the water. So the heat release will be measured or be absorbed by the water and by the calorimeter as well. So remember, it is not just the water who absorb the heat coming from the combustion, but rather the calorimeter itself. Okay, so water and the calorimeter, it measures or rather it absorbs the heat coming from the combustion as well. The special design of the calorimeter enables us to assume that no heat or mass is lost during the time the measurement takes place. Dahil po sa design or sa pagkakagawa or sa special design ng calorimeter na ito, we assume that there is no heat or mass lost to the surrounding. So again, if there is no heat or mass lost, therefore, this particular calorimeter is an isolated system. So again, we call this as an isolated system because there is no heat or mass exchanged or lost. Because no heat enters or even mass enters or leaves, the system throughout the process or the heat change of the system must be zero. Kasi nga isolated system. Walang heat, walang mass na nawawala o dumadagdag. Isolated system. The heat change must be zero. It's because of the special design of the calorimeter. So that's a constant volume bomb calorimeter. In simple, in its simplest technical process or definition. Now, from the concept discussed from the previous slide, we can write the following equation. The heat of the system is equal to the heat of the calorimeter. Cal, or the subscript cal means calorimeter, heat of calorimeter, plus heat of reaction, the reaction is combustion, must be zero. When the heat of the calorimeter and the heat of reaction are rather where heat of calorimeter and heat of reaction are the heat changes for the calorimeter and reaction, we can rearrange the equation. Alalahanin po natin, kaya po zero ang kanilang heat change kasi nga ito po ay alalahanin isolated system. So there is no heat or mass change. There's no heat or mass leaving or entering the system. Okay, so we can rearrange the equation into this one. Heat of reaction is equal to negative heat of calorimeter. So remember, it's equal to zero. Qcal plus Q reaction is equal to zero. So we can transfer heat of calorimeter on the other side of the equation. We can have it as a negative sign. Okay. Heat of calorimeter, this one, Qcal, can be calculated using the heat capacity. So heat capacity is represented by letter C, capital letter C. Remember that one, heat capacity, capital letter C is the symbol. So Ccal, that means the heat capacity of the calorimeter and the change in temperature. So Qcal can be calculated using heat capacity of calorimeter times change in temperature. Okay, again, let me repeat. From the concept that we learn that the bomb calorimeter or the constant bomb calorimeter is an isolated system, there's no heat or mass entering or leaving, we can assume that there's no heat change or zero. So rearranging this particular expression, transfer Qcal to the other side, we can have this relationship. Positive and negative. And that would entail or represent zero, isolated system. Okay, no heat change, no mass change entering or leaving the system. Okay, so that's why for us to compute for Qcal would be heat capacity of the calorimeter. Okay, or rather Qcal can be calculated by multiplying heat capacity of calorimeter Ccal times change in heat. So QCal, this one, can be calculated by multiplying heat capacity of calorimeter times change in temperature. Okay, so remember this relationship representing no heat change or no mass change. And then for us to calculate the heat of the calorimeter, we have heat capacity calorimeter times change in temperature. Example. A 1.274 gram sample of naphthalene, a pungent substance used in moth repellents, was burned in a constant volume calorimeter. Okay, so meron po tayong 1.274 gram na naphthalene na sinunog sa loob ng constant volume calorimeter. Okay? The temperature of the water rose from 21.49 degrees Celsius to 26.52 degrees Celsius. Ibig sabihin, nung nagko-combust o iniinit o ini-ignite ang naphthalene, yung temperatura ng tubig ay umangat mula sa 21.49 naging 26.52 degrees Celsius. If the heat capacity of the bomb or the CCal of the calorimeter plus water was 10.17 kilojoule per degree Celsius, calculate the heat of combustion of the naphthalene on a per mole basis. Okay, so we need to solve for the molar heat of combustion. Okay? Ang hinihingi ng sample problem ay isolve daw natin kung ano yung heat of combustion. Okay, so let us have here an example. Okay? So let's start by writing the given. Okay? So let me explain how the given came about. So the given, according to the whiteboard, mass of naphthalene, 1.274. CCal, that means letter C, capital C, heat capacity of the calorimeter, okay, 10.17 kilojoule per degree Celsius is provided. And then change in temperature. This is the change in temperature of water, 21.49 and 26.52. So final temperature minus initial temperature, we have here 5.03 degrees Celsius. Okay, so that's the given. And then the required, according to the problem, is molar heat of combustion in a per mole basis. When we say per mole basis, that means your final answer should be gram per mole. So this will be our final answer, or rather the unit of our final answer. Now, for us to solve the molar heat of combustion, and since this is constant volume calorimeter, ayan, binanggit na constant volume calorimeter. Eh, di ba, ang equation natin dito ay CCal times change in T. So, gagamitin lang naman natin ito. Okay? So now, let's answer. Step number 1. Okay, so look at the solution here found on the whiteboard. Heat absorbed by the calorimeter. So first step is we use this particular equation. So we use QCal is equal to heat capacity of calorimeter times change in temperature. Simple lang, dahil provided na ang heat capacity, 10.17, provided na rin ang change in temperature, multiply. We have 51.16 kilojoule. This is not yet the final answer. Why? Alalahanin, per mole basis. Okay? Gram per mole. I'm sorry about this one. This is not gram per mole, but our answer should be kilojoule per mole. Sorry about that. The final answer should be kilojoule per mole. Okay? Per mole basis, I forgot. So our final answer should be kilojoule per mole. Eh, kilojoule lang ito. So alalahanin, pag chemistry, dapat tama ang unit. Eh, kilojoule per mole basis daw. O, hindi pa tayo tapos, hindi pa titigil. So next. According to the whiteboard, heat of combustion. Alalahanin natin, ito po ay constant volume calorimeter, so heat of combustion. Since the calorimeter is an isolated system, alam natin na isolated system kapag constant volume calorimeter. The heat absorbed by the calorimeter is equal to the heat release. Katagalog po, kung ano yung init na inabsorb, ay equal din po ito numerically sa init na nire-release ng reaction. And remember, combustion is exothermic. Ang magiging itsura ngayon ng relationship ng heat of combustion or calorimeter ay negative heat of reaction is equal to heat of calorimeter. Diba ang calorimeter ng constant volume ay isolated? Isolated system. Pag sinabing isolated system, no mass or heat is added or released. So dapat Qcal plus Q reaction is equal to 0. Kasi isolated, dapat 0 yan. Ngayon, ang heat absorb, Qcal, ay equal sa heat release. Kung ano yung natanggap ng calorimeter na init, ay yun din ang init na nilalabas o nire-release through reaction. Itong reaction natin, ang uri ng reaction na meron tayo ay combustion. Technically, combustion is exothermic. Ano ang sign ng exothermic? Negative. Kaya po, kung i-rearrange natin ang equation, itong equation na ito, itong relationship, para mag-make sense na exothermic ang reaction, combustion ang reaction, ita-transfer sa kabilang side ng equation itong Q reaction, kaya po naging ganito. Negative heat of reaction is equal to heat of calorimeter. From this format, isolated system, sinabi, heat release. Ang combustion, laging exothermic yan, so laging negative. So, negative Q reaction. Kaya ito, from this particular form of the equation, we transfer Q reaction on the other side to represent negative sign. So, ito na ngayon. Negative Q reaction is equal to negative Qcal, or heat of calorimeter. So, ano na next dyan, sir? Ano silbi niyan? Next po niyan, di ba ang sagot mo sa Qcal, ito, heat of calorimeter ay 51.16. Sabi, Qcal is equal to negative Q reaction. 51.16, gawin mo lang negative. Ulitin. Qcal, 51.16 kilojoule. Ang Qcal mo equal sa negative na Q reaction. Since ang heat of calorimeter mo is 51.16 kilojoule, anong negative sign? Ayan lang, negative 51.16 kilojoule. This is your heat of reaction. Okay? So this is not yet, again, the final answer, not yet the final answer, because look at our requirement, molar heat of combustion per mole basis, kilojoule per mole dapat. Tama na tayo, ito na heat of combustion na, ayan na. Ito na yun. Heat of combustion na siya. Ito na yung combustion, ito na yung init galing sa combustion. Negative 51.16. Kaso ang hinihingi, per mole basis. Hindi ka pa pwede matapos kasi per mole. O dapat kilojoule per mole. Pero again, molar heat of combustion. Q reaction. Ang reaction mo ay combustion. Ito na yun, negative 51.16. Kaso nga, hindi pa ito pwede maging final answer kasi kilojoule lang. Ang hihingi ng tanong napaka-specific, per mole. Gagawin natin siyang per mole. Paano? Okay? Calculate the heat of combustion on a per mole basis. How do we do that? Ganito po. Remember, we have here the given 1.274 grams of naphthalene. Iko-convert lang natin ang grams into mole value of naphthalene using molar mass. The molar mass of naphthalene is 128.18 gram per mole. Just to save time, I already provided it here on the whiteboard. So convert lang natin, gram to mole of naphthalene. We have 0.009939 moles of naphthalene. So we now have a mole value of naphthalene. Ngayon, sabi, per mole. So yung sagot namin kanina na kilojoule, gagawin lang natin kilojoule per mole. Paano? Negative 51.16 kilojoule, yung sagot kanina, divided by mole value of naphthalene, we have negative 5,147 kilojoule per mole. Hence, per mole basis, kilojoule per mole. And that is now our final answer. Again, pwede na sana tumigil dito. Kasi kung heat lang ang hinahanap, compute for the heat of combustion, yan ang kilojoule, negative 51.60. Kaso nga, ang specific nung requirement, ang hinihingi, molar heat per mole basis. Kaya from this, we just converted the grams of the sample into mole value and divide Q reaction. With the mole value, you have a per mole basis. Okay? So I hope this is clear on how we compute how we compute under a constant volume calorimeter. Okay. Let me just click the slide. So this is just the same. This is just the same content of the slide. Okay. Okay, so I hope this is clear regarding the example for constant volume calorimeter. Next one. Let's have here constant pressure calorimetry. Now for constant pressure calorimeter, what's the purpose of the constant pressure calorimeter? Now the purpose of constant pressure calorimeter is to determine, calculate the heat changes for non-combustion reaction. Okay, so kabaligtaran naman. Kung ang constant volume, ito, constant volume, ito ang purpose niya kapag ang reaction combustion. Okay, pag ang reaction ng isang system at surrounding ay combustion, we use constant volume calorimeter. Pero kung ang reaction ay non-combustion, okay, so ibig sabihin hindi combustion yung reaction, constant pressure calorimeter calculation or system ang ating gagamitin. This device measures the heat effects of a variety of reactions such as acid-base neutralization, as well as heat of solution and heat of dilution. So ibig sabihin po, kung ang reaction ng sample problem ay neutralization, heat of solution, heat of dilution, constant pressure calorimeter ang gagamitin na calculation o equation. Okay? Kasi pang non-combustion ito. So neutralization, dilution, solution. Itong isa, itong constant volume calorimeter, pang combustion yan. Ayun, ito yung image ng constant volume. So pang combustion lang yan na equation. So pag sinabi ng tanong na non-combustion ito, neutralization, solution, dilution, itong particular na calorimeter equation ang gagamitin mo. Constant pressure. Okay? Because the pressure is constant, the heat change for the process, okay, so that is your heat of reaction, is equal to the enthalpy change. So this is what a coffee cup calorimeter looks like, or a constant pressure calorimeter. I mean, it's very simple. As in the case of a constant volume calorimeter, we treat the calorimeter as an isolated system. So the constant pressure calorimeter is also an isolated system, meaning to say there's no mass or heat being added or released. So remember that one. This is still isolated. Furthermore, we neglect the small heat capacity of the calorimeter in our calculation. I mean, look at the sample. You cannot see or you do not see any heat. Or I mean, you do not see image or illustration of ignition. Kasi po, balikan natin yung constant volume calorimeter. Ayan, no? May ignition siya. Ini-ignite. O sinisilaban. Itong constant pressure calorimeter. Constant pressure calorimeter, ayan, walang pagliyab. Okay? Or hindi siya sinisilaban. So once again, we will measure here the heat of water and also the heat of the calorimeter. So, I mean, rather the heat being transferred by the sample is transferred and absorbed by the water and the calorimeter itself. Okay? So from this assumption, okay, so from the assumptions mentioned by the previous slides and the definition of the constant pressure calorimetry, we can write the following equation. Okay, so heat of the system. Heat of water, yung init na na-absorb ng tubig plus heat of the calorimeter itself plus the heat of the reaction is equal to the heat of the system. Again, ang sistema po o itong system natin ay isolated. So we assume this is zero. Okay, so pag inad natin itong tatlong ito, our system or heat of the system would be zero. Kasi na-isolated. There's no heat or mass exchange or added or released by the system or the calorimeter itself. Furthermore, we also neglect the small heat capacity of the coffee cups or the constant pressure calorimeter in our calculation. So QCal is negligible. Okay, so ibig sabihin na negligible, hindi natin siya isasama sa calculation kasi sobrang liit. That means we have this one. Q system, i-omit lang natin itong QCal. We have Q water, heat of water, plus heat of reaction. So magiging ganito lang. Kasi nga, negligible itong QCal, tatanggalin natin. So from these three factors, we now have two factors. And then remember, Q system, or heat of the system, we have an isolated system, so the value would be zero. So therefore, para ma-attain o ma-represent natin na zero talaga at isolated ang sistema, walang pagbabago, we can transfer heat of water to the other side of the equation. We have heat of reaction is equal to the negative heat of water. Okay. However, this particular relationship changes. It depends on the type of reaction. Kasi for example, if water absorbs heat, so dapat positive ito. Ito naman negative kasi nga nag-release yung reaction. Pero nga kung absorb naman or rather nag-absorb ang water, so it's the other way around. So it varies. But nonetheless, this is the general idea of the constant pressure calorimeter. So let's have an example. A 26.47 gram lead sample at 89.98 degrees Celsius is placed in a constant pressure calorimeter. So sinabi na ng tanong na constant pressure calorimeter ang ating gagamitin of negligible heat capacity. So walang heat capacity, negligible kasi ganun ang constant pressure calorimeter. Containing 100.0 grams of water. The temperature of the water rose from 22.50 degrees Celsius to 23.70 degrees Celsius. So ibig sabihin, heat released at inabsorb ng tubig. Inabsorb ng tubig ang heat. So umangat. So kung nag-absorb ka ng heat, iinit. Siyempre. So from 22.50, it became 23.70. Now the question would be, what is the specific heat of the lead pellet? Okay, so let's have here the following calculation. So let me explain the following given. Okay, so our given are the following. Mass of lead, 26.47. Mass of water, why is it 1,000 here? Why is it 1,000? I'm sorry, this is supposed to be 100. So this is typographically incorrect. So this is 100.0 grams. Okay, 100.0 grams of water. And then our initial temperature is 89.98 degrees Celsius. Initial temperature of lead, as mentioned by the given. And then the change of water, or rather the change in temperature of water, is 23.17 degrees Celsius minus 22.50. Final minus initial temperature, you have 0.67. And then the requirement, according to the problem, is a specific heat. A specific heat of lead. And if you remember correctly, the unit for specific heat is joule per gram degree Celsius. So that means, as we end the calculation, this is supposed to be our final unit. And then, very clear and direct specific heat. So that means you just need to recall the equation for a specific heat. That's Q is equal to MS change in T. Okay? So let's solve. All right, so let's look at the following relationship. By treating the coffee cup calorimeter as an isolated system, alalahanin ang coffee cup or constant pressure. Iisa lang po. Ang coffee cup calorimeter at constant pressure calorimeter ay iisa lang po yan. Isang idea lang yan. Magkaibang pangalan lang. Ang constant pressure calorimeter or coffee cup calorimeter in other translations or names It's an isolated system. So alam nating isolated system siya. So since isolated system, okay, heat of lead. Okay, lead is our system plus heat of water is equal to 0. Kasi isolated. Walang heat, walang mass na madadagdag o aalis sa sistema. So dapat 0. Okay? Now, we can equate the heat lost by the lead to the heat gained by the water. So, next thing is ito, QPB plus QH2O is equal to 0. Alin ang itatransfer natin sa kabilang side na equation? Paano malalaman? Balikan. Ang sabi, ang water daw ay uminit, umangat. Ibig sabihin, kung uminit ang tubig from 22.15 naging 23.17, nadaragdagan, positive, endothermic. So dapat itong Q water mo, positive. Habang itong lead, ayan o, heat loss by lead, siya naman na maging negative, kaya QPB, negative QPB. So itong QPB, heat of lead, ang itatransfer natin sa other side ng equation. Okay? Ganon. Hindi lang siya basta-basta, parang trip ko Q water ang ilipat. Hindi. Iintindihin natin yung given. Ay, nasinabi. Umangat ang temperatura ng tubig. Kung aangat yan, endothermic. So, dapat positive. And that means, if heat is gained by the water, we assume that lead will lose heat. Kaya siya negative. Okay, so, hindi lang po siya basta-basta na, feeling ko ito ang negative or itong heat nito ang positive, ganyan. Hindi po. Ibabasahin po natin. Nakabase yan. So, heat gained by the water, positive, and then heat lost by the lead, negative. So ito po ang magiging relationship natin dito for this particular calculation. So next step, calculate the heat absorbed by the water. So isa-solve natin yung QH2O. So paano siya isa-solve? Specific heat. Ayan, nakalagay. Specific heat. Although, ang sinusolve po natin ay specific heat ng lead, okay? Alalahanin po na heat water is equal to negative heat lead. So in the long run, masasolve pa rin natin yung heat ng lead. We start with heat with water because look at the given. It's water, mass of water. Okay, so we can solve for ms change in T. Walang change in T ang lead. Ayan no, initial lang ang meron. Pero ang water meron, so pwede natin ma-change in T talaga yan. So we start with heat of water. Because when we solve heat of water, we can also solve for heat of lead. Ano, equal sila. So substitute, the mass of water provided by the problem is 100. So substitute. Specific temperature, or rather, I mean, not specific temperature, but the S value for this one. Okay, so that is S for water. That would be I mean, the specific heat, specific heat of water is 4.184 joule per gram degree Celsius. Remember, 4.184 joule per gram degree Celsius is constant specific heat of water. So you can search for that one. Times change in temperature. Change in temperature is 0.67, this one. So calculating this one, so cancel grams, cancel degree Celsius. You now have here joules. 280.3 joules. Okay? Now next. Ayan. Dahil ito ang, diba, itong relationship natin, buray natin ito. Ang relationship natin for Q water or heat water and Q lead is positive heat of water is equal to negative heat of lead. O dahil ang sagot natin 280. 280.3 joule. Anong negative value? Negative 280.3 joule. Meron na tayong heat loss by lead. We calculate or we have determined the heat loss by lead by using heat absorbed of water using this particular equation. Q is equal to ms change in T. Ayun, ms change in T. Q is equal to ms change in T. Heat. Sorry about this one. Earlier, I mentioned that Q is specific heat. Sorry, Q is heat. S is specific heat. Sorry, a while ago I was mentioning that S is, I was mentioning earlier that Q is specific heat. Okay, so I redact that. I'm sorry about that. Q is heat. So the equation, main equation is heat is equal to Ms change in T. Okay, so that means our heat is 280.3 joule for water. And since we have computed for the heat of water and the relationship is mentioned here, that would be negative 280.3 joule heat loss for lead. Okay. And then next step, we just simply use or solve for the specific heat of lead. So coming from the equation, Q, PB, so this one, Q is equal to Ms change in T. So you have here Q is equal to Ms change in T. Rearrange the equation, we have this one. Okay, so how do we do that? So we just simply Q is equal to Ms change in T. So we need to isolate S. Divide both sides by M, change in T. You have this one. Okay. S is equal to Q is equal, specific heat is equal to Q or heat all over mass times change in temperature. Okay. Right. The next step, substitute QPB, that is your negative 280.3. Mass. The mass of lead is provided, 26.47 grams. And then change in T. This is the final and initial. So the initial is 89.98 degrees Celsius. Now, why is it 23.17? Bakit ang final temperature ng lead ay 23.17? Kasi po, tandaan natin, balikan natin yung image ng constant pressure calorimeter. Ayan, no? Yung sample po ay kasama siya sa tubig. So kung ano po yung final temperature ng tubig, yun na din po yung final temperature ng sample. Titingin ko po. Ang initial temperature ng lead ay 89.98 provided. Pero bakit ang final temperature niya 23.17? Same with water. Ayan, nakalagay sa given or sa problem. Kasi nga po, kung babalikan natin yung image or illustration isang coffee cup calorimeter or what we call this one, constant pressure, ayan no, yung sample nakasubmerge sa tubig. So, ibig sabihin kung ano yung final temperature ng water, yun na din ang final temperature ng sample. Okay? So, after this, substitute. So, just will leave degrees Celsius. So there will be no unit cancelled. Hence, we have the answer 0.1585 joule per gram degrees Celsius specific heat. Okay, so we have solved the specific heat of lead. And remember, this is still, or this is indeed the unit for specific heat, joule per gram degree Celsius. And joule per gram degree Celsius. And our final answer is indeed joule per gram degree Celsius. Okay. So I hope that was clear in terms of our example for constant pressure calorimeter. Okay. All right, so these are the following lesson objectives for this particular lecture. I hope this was achieved. Number one, differentiating bomb calorimeter and coffee cup calorimeter. Remember, constant volume calorimeter is used for combustion reaction. Combustion. Whereas coffee cup calorimeter or constant pressure calorimeter is used for non-combustion. Okay, non-combustion reaction, just like this one. Just like this example. Okay. So those are non-combustion reaction. Non-combustion reactions are heat of solution, heat of dilution, acid-base neutralization. Those are non-combustion. So those are for coffee cup calorimeter. And then for number two, calculate heat changes using constant volume and constant pressure calorimetry, which we have also provided and discussed. Okay. All right, so I hope you learned a thing or two about constant pressure and constant volume calorimetry, its differences, when to use them, and also its calculation. Okay. Thank you, and I hope you have a great day.